Okay, we have an arrow. This arrow is shot 30 degrees above the horizontal, like we said. So if this is the horizontal right here, dot, 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 you can put the horizontal anywhere. Something traveling above 30 degrees above the horizontal means that the velocity is pointing above the horizontal like that, okay? So I got Katniss right here shooting her arrow, but you know what? I'm going to change this, sorry Katniss. I'm just going to make this a ball. Let's get rid of Katniss. It's kind of hard to draw an arrow. Okay, she's gone. Okay, so we're going to set this up like this. So we got a soccer ball. We'll just switch the arrow to a ball. Same basic thing. So the velocity is like this. V initial is 49 meters per second. This angle right here is 30 degrees. First thing you should recognize, like right away, you should go, that 49, is it perfectly X? No. Is it perfectly Y? No. So what do we have to do to it? Break it into components. So that 49 meter per second has an X velocity and a Y velocity. So that's Vx. This is Vy. Now how do we get Vx and Vy? With trig. All this is, from trig class, all it is you got 30-degree triangle, the hypotenuse is 49, solve for the x sides, that's all it is, right? So how do you get the x side? Sine or cosine? The x is going to be cosine 30 times 49 meter per second. The y is going to be sine 30 times 49 meters per second. Okay? So those numbers come out as the x value comes out as 42.435. 42.435 meter per second. The y value comes out as 24.5. Okay, so then the object goes like this. As it flies through the air, I switched it from an arrow to a soccer ball, but the same basic thing. It goes like that. Now, what do we know about the x acceleration? Acceleration x is what? 0. And don't just memorize this. What does that mean, that the x acceleration is 0? If you look at the ball at any point here, right, what do we know about the x velocity? The x velocity is going to what? Stay the same. Vx is going to remain 42.435 meter per second, right? Over here, this is going to be 42.435 meter per second. Hey, does that happen in real life? No, because in real life, there's air resistance. Here, we're assuming no air resistance. Okay, now, does the y velocity stay constant? Does y velocity remain the same? No, because what acts in the y direction? Gravity. So here's what happens. The y velocity from here to here, the y velocity, it's going to be there, but it's going to be smaller, right? Instead of being 24.5, it's going to be something smaller. Now, what do we know about Vy at the maximum height? 0 for a split second, right? At the very, very, very top, it's only moving in the x direction. Don't memorize it. You should understand it. Okay? All right. Now, let's solve this. First question. How high will the arrow go? Or, in this case, the object. Change it from an arrow to a ball. All right, so how do you find this out? We're looking for y max, the maximum vertical height, right here. So how are we going to figure this out? With a kinematic. You're using the motion equations. Okay, so the equation that solves this, Vy final squared equals Vy initial squared plus 2Gy. That's the fourth kinematic on the list. I just wrote it for the y direction. Yeah, I'll give you the motion equations. Okay, so up here is the final. Down here is the initial. What do we know about Vy at the final? Up here. At the very top, what do we know about Vy? It's 0, so now you can solve this for y. Y will be negative Vy initial squared over 2g. So this is going to be negative. Now what was the initial y velocity? 24.5. 2 times gravity is negative 9.8. So the negatives cancel, and we end up with y maximum being 30.6 meters. That's the max height. Okay, question B. It's a two-part question. So let's see. You're gonna make some room here. So look, you gotta solve for two things. In doing question B, the first thing you have to find is what? So the question is, what's the horizontal distance the arrow will travel? So from here to where it lands, that is what we're looking for. We're looking for how far it travels horizontally. What do we need to find first? The time in the air. You have to find time first. Because why? Let me just give you a preview to step 2. Once we have the time, guys, there's only one equation for the x direction. Do you guys remember that from last week? For the x direction, for this direction here, what is the only equation for the x? X equals vxt. The x velocity multiplied by time is how far it travels horizontally. Okay? What's the reason there's only one x equation? This is the reason right here. The acceleration in the x is 0. Okay? So once we have time, we can just plug in here. Do we already have the x velocity? Yep, we got the x velocity. All we need is time. So how do we get time? Well, what I like to do, solve for the time up. If you can find the time up, what do we know about time up compared to time down? They're the same. So let's solve for what time up is. So using this equation, Vy final equals Vy initial plus gt. What is the y velocity at the tippy top? 0. So now you're left with, when you do the algebra, so take this, solve it for t. T is going to be equal to negative Vy initial over g. So negative, the initial y velocity is 24.5. Gravity is negative 9.8. So this comes out as 2.5 seconds. So what's the total time in the air? So the 2.5 seconds is to right here. That's halfway. So what's the total time in the air? 5 seconds. So now we can solve for x. In fact, I'm going to do it right down here. Finding this x, we go x equals vxt. Well, what's the x velocity? 42.435. The time in the air is 5 seconds. So this comes out as 212 meters, which is the answer to B. The answer to B is 212 meters. But you had to find the time first. Okay, last question. What will be the arrow's velocity 2 seconds after being shot? Okay, so we got to go back here. So it started right here, went up, 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 up. Now look, where's 2 seconds going to be? On the way up or the way down? On the way up. So let's say that right here is 2 seconds. This right here represents t equals 2 seconds. At t equals 2 seconds, it's moving like that, right? It's kind of going that way. This is what we're looking for right here. How do we get that velocity? Well, it has an x component and a y component. This x velocity never changes. It's 42.435. This y velocity we have to calculate. You got to find that y velocity. How could we get that y velocity? Well, you go like this. Vy final equals Vy initial plus gt. What was the initial y velocity? Not 0. The initial y over here, it has x velocity, y velocity. That initial y was 24.5. Gravity's negative 9.8. Oh, hold on. 2 seconds. Look, almost done. Vy final. The final y velocity is 4.9. Now look. How do you get this total velocity there? Pythagorean theorem. You do Pythagorean theorem and you get 42.7. And then solve for this angle using trig. And you get 6.6 degrees.